Today's notes deal with reflections, and this is a pretty easy topic from a long time ago. You've probably seen the word reflection before. You see your reflection in a mirror, so it's not a crazy concept. It's really applicable. So line of reflection. So that means if you have two shapes, and maybe they're drawn like this, where would the line of reflection be? Yeah, it would be right in between them, exactly in between them. So that means this shape would reflect over to there. And a lot of times they'll put some letters on them. They'll say A, B, C, and you need to make them correspond. If this is B, this will be B prime, A prime, and C prime. So that's a basic example of a reflection. Now, one thing you got to keep in mind is it's not always going to be pretty like that. Sometimes they'll take that whole picture and they'll maybe rotate it, and you have to visually be able to see that it still rotates over that line. You still need to be able to decide where that line is. So we're going to be talking about this kind of example a bit more today because a lot of people have trouble when it's not a vertical line of reflection or a horizontal line. When it's diagonal, that's when people struggle a little bit. So what is a line of reflection? Okay. All right, so probably a good definition for line of reflection is the line that a shape is reflected over and the key thing is that that line is equidistant from all corresponding points. The line, or sorry, yes, that line is equidistant from all corresponding points. So what does that mean? That means the distance from B to that line is the same as the distance from B prime to that line. These distances will be the same. The same for A to the line will match A to the line. Obviously, they're a little staggered. And then C to the line will match C prime. So C to C prime. So please keep that in mind, and really they should be touching. So I didn't align them very well, but they should be touching whenever you draw that line straight across. On this next example, it says the vertices are given, graph the reflection of triangle ABC, which is described. So we're going to be first reflecting over x equals 2, then we're going to reflect on the other shape, or on the other graph, over y equals 3. So the problem is this. Knowing how to graph this is an Algebra 1 topic that a lot of people struggle on. Here's how I remember how to graph x equals 3. I'm going to hit the x-axis at that number. I'm going to hit the x-axis at 2. So I find the x-axis, here it is, and I'm going to hit it at positive 2. I want to draw a line through that point. The line is either going to be horizontal or vertical. If it was a horizontal line, what would they have called it? They would have called it the x-axis. Did they say flip over the x-axis, though? No, so it's not a horizontal line, it's a vertical line. That's the line we're going to reflect over. Another way to look at that is this. Some people like to create a little table. And on this table, all my x values better be 2. And the y values I can make up. Where's the 0.21? Over 2 up 1. It's right there. Where's the 0.22? Here. Where's the 0.23? Right here. And you can see that it generates that line that we previously graphed. Those are two ways in which you should be able to graph those lines. And if you can't graph them correctly, you'll have some trouble. Now we need to take a little bit of time and graph these triangles. So let's go ahead, graph the original, the pre-image, and then we'll graph the image. After you have that shape graphed, make sure you label the vertices with their letters. Make sure you label it. And then we're going to complete the process of reflecting over that line, x equals 2. The key concept I want to get you here is I want you to understand that every point must be reflected over that line. How far is C from this line? Well, along this way it's 3 units. So I need to continue and go 3 units in that direction. There's my C prime. How far is A from that line? Okay, right now it's 1 left, so I need to do the opposite and go 1 to the right. So there'd be my A prime. How far is B from this line? It's 1 to the right, so I need to go 1 to the left, and there's my B prime. Now I can connect them, and there's my reflection. Now on this next one, it says we need to reflect over the line y equals 3. Well, the basic way I remember it is hit the y-axis at the number 3. Hit the y-axis at the number 3. So there's 0, 1, 2, 3. And I can logically think, which way is it going to be? What do you all think? Is it going to be a horizontal or a vertical line? Well, if it was a vertical line, what would they have called that? The y-axis. Did they say flip over the y-axis though? Nope. So it's got to be a horizontal line then. Once again, you could do that table method. On this one, all my y's should be 3. And then make up your x values. And if you graph these points, over 1 up 3, over 2 up 3, over 3 up 3, you're double checking that you're generating that correct line. From there, we need to graph our shapes again. So go ahead and graph that ABC from the original statement. After you have that original triangle graphed, we do the same process we did up here. How far am I from this line? A is 1 unit down. I need to do the opposite and go 1 unit up. So there's my A prime. How far is B from that line? Well, trace along the grid. It's 3 down, so I need to go 3 up. And C is on the axis, or sorry, the reflection line, so it stays on the reflection line for C prime. And there's your reflection. You can see that it's reflecting over the axis. I'll give you a little bit of time. Go ahead and try out this checkpoint. All right, so checkpoint 3 says take that shape from the previous example and reflect over y equals 2. So what was the little phrase I said to know how to graph y equals 2? What was I saying earlier? Hit the y-axis. So it's y-axis is where we touch at the number 2. So find the y-axis. Here it is. Hit the number 2. Now you got to think, is it going to be horizontal or vertical? It's going to be horizontal. You know that because if it was vertical, it would have been just called the y-axis. They didn't say reflect over the y-axis though. All right, I got to reflect over this blue line now. Anytime it's on that line of reflection, it's not going to move. So A prime will be in the same place as A. But this C letter is 1 up, so I need to do the opposite, which is 1 down from the line. There's my C prime. And my B is 2 down from the line. I need to go 2 up from the line. There's my B prime. And now I can connect. And it should look like that. Example 2 is where people start messing up. Because on example 2, it doesn't give just a horizontal or vertical line to flip over. Instead, it's a diagonal line. And this diagonal line is right here, y equals x. So in case you've forgotten what y equals x is, you can think about a table. And I want my y to be the same value as my x. So I'm going to make up some numbers, 1, 2, 3. I want my y's to be the same, so what should they be? 1, 2, 3. Now let's graph those points. 1, 1, 2, 2, 3, 3. Can you see the line that it's creating? It's creating a diagonal going through the origin. It looks like this. So there's my line, y equals x. After you have that line graphed, you need to make sure you can graph that segment. It says graph CD and reflect over that line that was given. So CD, so C is negative 2, 2, and D is positive 1 up 2. There's my segment CD. I need to reflect over that line. Now earlier we talked about counting along the grid, but we can't count along the grid in the same way anymore. So be careful, be careful. This time, whenever we're reflecting over diagonal lines, we're going to count diagonal distances to that line. So look at C. C is right here. I need to count how many diagonals I am from that line of reflection. So here's a diagonal. There's one diagonal, two diagonals. I'm 2 diagonals away from that line of reflection. What I need to do is I need to continue going in that direction. How many diagonals? 2 more. So here's 2 to the line. I need to go 2 away from the line now. So there's 1, 2. There is my C prime. Now be careful though. How many diagonals is D from the line? Yeah, it's only half a diagonal this time. So if I go half to the line, I need to go half away from the line. And there's my D prime. Now I can connect them. And if you want, you can rotate your paper and kind of eyeball it. Make sure it's a nice, even reflection. On example 3, it says reflect CD from example 2 over the line y equals negative x. So we need to think about that line right there. It's a little bit different from what we had earlier. It's a little bit different. The earlier one was y equals x. This one is y equals negative x. So if I say my x's once again are 1, 2, 3, what are my y's going to be? They're going to be the opposite sign, right? Negative 1, negative 2, and negative 3. That's what this means. They're different signs. They're opposite signs. So I need to be able to graph those 3 points now. Over 1, down 1. Over 2, down 2. And I think you can get the idea. It's going through the origin the opposite direction. From there, we need to graph that same little segment, CD. And it gives us the points over here. C is negative 2, 2. That's actually on the line. And D is over 1, up 2. So there's my segment CD that I need to reflect over that line. Now C is very easy because C is going to be on the line of reflection. It's not moving. C prime will not change. There's my C prime. Since it was already on the line, it's staying on the line. But what do I do with that D? How do I figure out where D should end up? Count diagonals. When you're reflecting over diagonal line, you count your diagonals. Now be careful. This is one whole diagonal, and then how much to the line? Half. 1 1/2. So here's my half, and there's my one whole diagonal. There's my D prime. And remember, you can turn your paper, eyeball it, make sure it's a nice, even reflection. Try out these checkpoints real quick. See what you can do. All right, so here are the checkpoints. Here's the original JK. We wanted to reflect over that line y equals x. They already give us y equals x, which is real handy. So once again, we see how far is J from that diagonal line. We count diagonals. This is a half diagonal. We continue in that direction, another half diagonal. There's my J. I now go over to K. I'm going over a diagonal line, so I count diagonals. There's one full diagonal. There's a half diagonal. I continue in that direction, 1 1/2, and there's my K. Over here, JK, same thing, reflecting over a diagonal line, you count diagonals. So here is 1 diagonal and a half. There's a half, then 1, there's my J prime. Once again, here's K, the half diagonal, continue half diagonal, there's my K prime. All right, example 4. Now this one's kind of tricky, but this could be a good quiz or test question. So make sure to note this one. It says workers are retrieving tools that they need for a project. One will enter the building from point A, the other at point B. Where should they park on the driveway M to minimize the distance they'll walk? So here's the driveway M right here, and here they are at A and B. They got to figure out where they should park. So what they do is they try to draw this little picture down here. They want you to focus on this because it shows the same thing up here without the barn. So you can just focus on this piece. So today we talked about what major topic? Reflections is the key thing. So I want to be able to reflect those points over the line M. And M is representing your driveway. So A reflected over, and we're just going to kind of have to eyeball a little bit. If you had a ruler, that would be great. So A reflected over, you go perpendicular, and then same distance right there, there's my A prime. B is going to do the same thing. Here's that distance. I want to repeat it. There's my B prime. I've reflected each of those points over the driveway, which is line M. But what we need to be able to do is figure out where is the best place to put their tools along this driveway based on where they are right now, so they don't have to walk as far. To do that, what you need to do is connect the opposite points. And if I had a ruler, it'd be nice and clean. But once you connect those opposite points, they will intersect on that driveway. And that's where they should place the tools. This works also if one is close and one is far from the driveway. You'd reflect over. There's A prime. I would draw this. And you'd reflect over the B prime. And now once again, you connect the opposite points. So here's B. And so this would be the best place to put it. So it's definitely longer, but what it does, it minimizes the total distances that they will have to walk. So a lot of people would just say, all right, kind of put it midway, but that wouldn't minimize the distances they will walk. This method will minimize the distance, however.